Once again, good morning. My name is Dase and I'm Associate Data Scientist. Today we are going to focus on matrix, and then I hope that you enjoyed the last session on vector, where also we have seen the vector and the matrices, list and data frame is the common data structure we used to use in data analysis. And I hope that you are going to see the difference between vector and the matrix. As we have seen in introduction, we have seen that the vector, it is a one-dimensional data structure that is store the data in the same data type, and also the same as to the matrix, they store data in same data type, but also in two dimension, not one dimension. If I say two dimension, understand the row and the column, but for the vector we covered, it is one dimension. We don't have the value in column, don't have value in rows. So we are going to see what is the rows and the column that we are talking about the matrix, and I think we are going to understand it better, so that it is going to help us to master it before doing the real life scenario based. So let's jump to the introduction to the matrices. And here I was like saying that when we are creating a matrix, can be combined by combining the vector either row wise or column wise. So if we say the column, most of the time you will hear those technical terms a lot when it comes to the analysis. If we say the columns, we are talking about the variables. Let's say if I say the variables are that I'm talking, not object that we really know, like age, something like that, but understand the variables in terms of, like, I'm going to the field. I want you to understand it in a real life situation. So I'm going to the field and then to conduct the study, where I will need to ask what is your age, what is your gender, what is your education level, what is your marital status. Those questions that I will ask them so that I will get the result. That's what we call column. That's what we call variable in real life. And then the responses that they are going to give me, let's say, for example, if I will ask you the question and then you say, I ask you the marital status, you say that I'm single, I'm divorced, something like that. So those responses that you provide to me, since I was asking you that questions, that's what we call rows. So normally in a real life situation, we used to say as observation, but when it comes to the matrix ways or the data frame sense or the other programming, they call it they call it rows. So those observations we get from the field, that's what we call rows. And then those variables, those questions that we are asking them so that we can get the result, it is also what we call variable, but when it comes to the other programming, we say the column. So I think you understand it. And yet for the matrices, as we have seen that it is two-dimensional. It is composed by row and column, but the same data type. That is what we need to have. And note that all elements in matrix should be in the same data type. Of course, you cannot have the matrix of the names of the people and the age at the same time. It cannot work. We will have to say that if I'm going to generate the matrix, I make sure that if it is an age, both of them it is a numbers. That's what I can say. And you can create the matrix either by using row wise or the column wise. So we have the column number one. We are generating the vector. So the interestingly, it means that when we are creating the matrices, we normally based on the vectors. So we normally based on the vectors where we are going to combine the vectors that has the same data type and also the same length. I want you to understand this. If we are creating the matrices, we are making the comparisons. We are making the comparisons. We are making the combinations of vector that has the same data type and the same length. So if I say length, what it means? So if I'm saying length, let's say for example, you have 1, 2, 2, 3, 4, 5. 5 observations here. So what I'm trying to show you, I'm trying also to generate the columns that has like the 5 options. So I will make sure that each columns that I'm going to combine with have the same data type, but also each of them has the equal length. I think you understand the length. So we can create the matrices from these factors or these factors as vector, as the following example, where you can use the C-bind. If we use the C-bind, what we are talking about, we are trying to combine the matrices by using the column bind. So, and of course you can create the matrices by using the other bind, where it is the row bind. So we are going to see the difference between it in example. So creating the matrices also, most of the time when we are creating the matrices, we are creating the matrices from the sequence. As we have seen the sequence operator, it is like I don't want to type a lot, but I can command the other programming so that they can generate it for me. So this is the examples of how we can create the matrix. So we type the matrix and then we say data equal. It is going to be consist of the numbers from 1 up to 12, where rows is going to, number of rows is going to be 3 and number of columns is going to be 4. So for you, you have a responsibility to command the weight. That is 3. That is what we call the dimension. So, and then the matrix and number 2, you can use also the matrices function, and then you put the opening bracket, and then data from 1 up to 12 is going to be consist of 1 up to 12. Number of rows is this, number of this is this by row, something like that. So the length of the sequence should be submultiple or the multiple of the numbers of the column. So the name again here, so we are naming the rows and the columns of a matrix using row names. So let's say, for example, you can have the matrices which is not named, and then you need to make sure that to make it appropriate. Like I was maybe having numbers 5, 6, 7, something to those numbers, but I don't have age, numbers, attempt, those kind of things. And then I will need also to name it so that it can be easier for me to have it. You know, those who knows mathematics, most of the time the matrices are not labeled like this one. So we will use the function like column call names to name, to put the name of the matrices, to label the matrices, or row names. It will depend. If I say the core names, as I told you, the column, it representing the variables, like it is in a vertical way. So that's what I can say. The vertical way, that is the variables that we are saying. So the age, attempt, the numbers, the attempt, that is also the column. Column number 1, column number 2, column number 3. But if we are saying about the rows, row number 1, row number 2, row number 3, row number 4, row number 5. So the row, it is horizontal way, horizontal wise, and then the column, it is the vertical wise. So from here, so if we need to add the labels, like the names, we will use code names and then put the name of matrices, put equal, and we are going to use concatenate functions where we have seen it in vector. So the concatenate functions, it helps us to combine. If we need to assign more than one values to something, we will use the concatenate. That is going to help us to combine those values that we really want to add on. So here, that's what we have done. And here, row wise, we are trying to label on this side. Since we have already labeled on this side, we are trying to label it in this side. So, and I think you understand the difference. So Again, we are naming the rows and the columns of matrix using dimension names. So the dimension name or dim names command can set query that rows and the column names to the matrix, and right-click the row names and the column names. We can also use the dimension names instead of using row names and the column names. So the only difference is the dimensions you can do it at the same time. So we are going to see it in practice. So the dimension names, you can use it in the same time, so where you can create the labels on the names and the labels on the rows and the columns at the same time by using them something. So you see what you have to know. The dimensions, it is a row times column. The values that I started with here, it is going to be on the row, this one, January, February, March. So, and another value that is going to be our second, this is row times column. If we say dimension, understand row times column here. So if we say dimension, understand the row comes first and then as followed by the column. So getting dimension of matrix, you can get the dimension of row and a column separately for both at the same time. So n rows to see number of rows of the matrices. For example, if you see to get the number of rows and matrices on matrices, you use n rows, but if you are interested to see number of columns and columns, the dimensions, they are going to bring the number of rows and a column. What comes faster, it is also the rows, and the second one is the column. So if you type dim and then you add the name of matrices, it's going to print for you the dimensions of your matrices. So maybe you can ask a question to me like, why can't we calculate the dimension since we can count it like in simple way? Let's suppose you have a data set that has more than 20 variables and you don't know, you are not going to scroll by reading those kind of things. So we will see it when it comes to the big data set, where you will need to say that the survey was conducted about maybe 2,500 people, and I was asking more than 60 questions. Those questions that is going to be represented in terms of columns, and the observations, the answers they give you to that question is going to be represented in terms of rows. So that's where we need to know the number of rows, number of observations. So if I say number of rows, understand number of observations in applications. And if I say number of columns, understand number of variables, number of the questions that was asking to the respondent, asking to the participant. So we will need to understand those kind of things for better understanding the data set, but also for reporting the output of what we are doing. So again, we are looking for subsetting. If we say subsetting, we are trying to difference, to look for the specific values in inside the matrix, as we have seen it in vector. It is, if we say subsetting, I'm trying to look for the specific value inside. So to get the subsetting of a matrix, we use the brass, or the same thing to the vector, we use the square brackets. For me, I used to say square bracket with two elements separated by comma. The why we say the two elements, one it is representing the rows and one is representing the columns. So if I say I need to see the values that in position number one, something like that. So we are going to see it as an example. So let's use the matrix we create above that we call the matrix. So there is a matrix we create above here, and then we have named it as matrices. I don't know where it is, but we have created the matrices and then we call it matrix A. So and then, so what we are matrix A, I think you have seen it. So if I say matrix A and then I put the square bracket, I put 4. What it means, if I put 4 and I put comma, It means that I'm trading the arrow that go on my matrix and look for all the values that is in row number 4. Bring it to me. Select the row number 2. That's what row number 2, it is 898. You see, if we come here, row number 2, row number 4, so matrix A, this is matrix A, row number 4 is 898. That's what we are getting here. So, but if I put the comma and then I indicate the last number, as I told you, the first numbers that we have here, it is representing the rows, and the second number, it is representing the columns. But if you need to specify only rows, let's say for example you are interested only to look for rows, you will put the numbers and then you put the comma and then you continue. But if you need to look for the columns only, you will need to type the columns and then you will have also to specify those kind of things. So that's what you can also do. But if you need to look for the, let's say, this value, you have to indicate the rows and the columns at the same time, where you can say the 4 comma and then you put the column number of these kind of things at the same time. And here, that's what we have done here. So not correct. So what we are trying to look for here, we are trying to look for the matrices where we need to see the row, where we are trying to look for the row number 2 up to row number 4. So I'm trying to look for row number 2 to number 4. So it is going to bring row number 2, number 3, number 4 for all observation, because I didn't mention the columns that I'm going to look for. But here you can also indicating the columns that you are looking for. Here it is where we are saying that we no longer need the rows, but also go and bring the column number 3. So I think you see how we do subsetting the matrices. What you need to know, it's like either to choose if you are going to look for the columns or the variable or the rows, or if you are going to look for rows and the columns at the same time. So what you need to know is just like when you are going to separate it, you used to use the comma. So that is the keyword. Otherwise, we use the square bracket and other thing is going to be the same. So, and then we are using calculations with matrices. What I have told you, it's like to make sure that if we are going to make the summations of the matrices, make sure that the matrices has the same dimension, same row and same columns. That's what I can told you. So make sure that it has the same rows, same columns, and then do it to the way. When we are multiplying the two matrices, of course, we will use the star, or you can use percentage star percentage operator. So that is going to be the same. So A times B, the matrices should be in the equal the same dimension. So dimension like a number of rows and the columns at the same time. So you have to make sure that are the same, so that it's going to be the same. And another function is that is also applied to the matrices. You can use the row summation. You can see the summation of rows. You can see the column summation. You can see the row mean. You can see the column mean. Whatever you want. What you need is like to type the code the way it is. Like here, we are going to see it in a practical thing. You can type the row sum and the column sum, the row mean, column mean. Those are things you can do. What you have to do, it's like to follow the procedures and make sure that the code is typed well, and also understanding what is going to bring for you. And I think you understand what mean it is, what median, what the standard deviation. If you see that those are the things you need to do in your analysis or in your applications or your practical things, so you will also have to do it, but make sure that you understand what you are going to do first. So in a conclusion to the before we go to the practical side, so matrix is two-dimensional data structure in R. and is also correcting the element of the same data type and arranged in rows and columns. And matrix can store also can also store the numeric, character, logical data, and also create using a matrix function. Or either you can use row bind, C bind, those kind of things we have seen, and the elements are accessible by specific rows and columns indexing or subsetting that we are talking about. So the matrices support the arithmetic operations, functions, and transformations. So, and they making them useful for mathematical and statistical computation. So, without taking much time, so we are going to look for the practical side. So, we are on the practical side. We are trying to look for the what is matrices. You have seen it, like the way we are generating the matrices. So matrices, you can also say equal and then say matrix from 1 up to 12, where we are going to indicate the number of rows and the number of columns that you are talking about. And then from here, so you will also need to indicate those kind of things, and you will feed by row, and also you have to feed it by columns as the way I will tell you. And if you need to check the number of rows, the number of columns, the dimensions, the classes, it is the same. So what we need to see, it is just to say to look for matrices. You say matrix number 1, matrix number 2, we are generating it, but also indicating the number of rows and the number of columns. And here it is the same. I'm generating the matrices, which is a character. So by using character data type, I indicating the number of rows. If I say the number of rows, you see what I'm going to see. And if I check is dot matrices, I'm asking myself if these are matrices. And here I'm assessing the element. I'm referencing, subsetting that we are talking. So here I'm subsetting the row number 2 only, and this is also the comment that I provide you so that you understand what it means. But also you can replacing, modifying the element where you say that the value that is in position 1 and 1 column on the column number 1, row number 1, go and replace it with 100. The value that is in the second column, go and replace with these values. So those are also the modifying. So I was trying to help you. This is combinations of vector into matrices where we will use C bind, R bind, the way we have seen it. So we are combining by rows. So which means this is 1, 2, 3, 4. We are going to have we are going to have 3-dimensional matrix, row bind. So those are the kind of things. And then column bind, we are combining the matrices based on the row bind and C bind. So that is also what we have seen, the matrix operators, where we can say matrices, we say A plus B. We can also do the multiplication, subtractions, additions, and the division. But we have, what we have to make sure it is just to make sure that the variable or the matrices that we are looking for having the same data type. So not only that, but also you can calculate to see the length, number of total element that is in the matrices. You can also see the number of rows of matrices, number of columns, dimensions, row times column. Row and the columns at the same time we use dimensions. Row sum, you're trying to see the total of the rows, the total rows of your matrices. Column sum, the total columns of your matrices. Just in total to see the total. Let's say you have the income, you have age, you have whatever, then you need to see the total income in position in row number 2. You will use row sum, column, the row mean, the column mean, diagonal. You see, those are the things that we need to see. We are naming also again to name the matrices, we have seen that we are naming matrices by using row names or the column name, or we can use dimensions to name it at the same time. So I think you have seen a lot on matrices, and this is the practical examples, and what you have to do just to understand those kind of things. You have to master it so that is going to be easier for you. So once you understand the logical behind the matrices, it is going to be easier for us once we are trying to look for the data frame, because the only difference between the data frame and the matrices, it is because the data frame can store the data in the different data type, but also the matrices, they store the information in terms of row and the column, and at the same time to the data frame, the data is going to be stored in terms of row and the column, where columns also indicating the variables in the real life situation, or the question is that we are asking the respondent from the field, and the rows are those observations we receive from the field, or the responses we get from the respondent. So but for matrix, we have to make sure that it has the same data type. If it is a matrix of a numeric, make sure that it is a numeric. If it is a matrix of a logical, make sure that it is a logical. And if it is a matrix of a character, make sure that it's a character. But for the data frame, it is not the case. So it can be the combinations of those three data type and more. So it is not going to be a burden regarding to the data type. And sometimes the dimension are not always to be equal when we are trying to make the calculations, because we will assess, we will subsetting the columns by columns independently. So that's what we need to see. And those who knows mathematics, you can also calculate the determinant, can also calculate the inverse, the square of matrices. Those are things we need to see. If I'm trying to see the determinant of matrices, so we'll see how you can use it. The transpose, those, there is a road, we cannot cover it just in a few minutes, but also what you have to do, it's like to make more research. You read the additional materials that we put on system, so that it's going to be easier for you. And this is an examples that you have to look for. Don't copy the code, just I want you to read the exercise and do the same. I provide you the responses on each exercise, but I don't want you to copy and paste the code. So make sure that you do it better, so that it's going to be easier for you. And I hope that you enjoyed the session. Let's meet to the next session, where we are going to focus on the list and data frame. So thank you so much for making this course to be enjoyable.